Alright, so for example number 3, we are going to confirm that the function is differentiable by finding the function f prime of x using the difference quotient. Alright, so using the difference quotient, we're looking for the derivative of the function. So again, it's going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. So again, we're going to take the given function and in for x, we're going to plug x plus h. So in for x, plug in x plus h. In for x, plug in x plus h. Okay? So again, we are evaluating this part of the difference quotient by putting x plus h in for the x's. X plus h squared plus 3 times x plus h. Then we need to subtract the function of x. So again, that's just x squared plus 3x. And that's all over h. Alright, so we got some evaluating to do, some simplifying I should say. Sorry, some simplifying here in the numerator. X squared plus 2xh plus h squared, and that's squaring x plus h. This, distribute the 3. Here we distribute the negative, and all over h. Alright, so here we have some combining like terms. The x squareds and the negative x squared cancel. Positive 3x and negative 3x cancels. Alright, so now we're left with these terms right here. Got an h squared. I've got a 2xh and a 3h left in the numerator. Alright, so I can simplify this. These all have a common factor of h. So that's going to cancel with this h in the denominator. So now I have h plus 2x plus 3. And again, this h canceled with one of these, this, and this. It gave me h plus 2x plus 3. So evaluating this limit, h goes to 0. Plugging 0 in for h, I'm left with 2x plus 3. Alright, so this right here is the derivative of the original function. Alright, so for this last example, here we have an object that's being dropped from the top of a 100-meter tall building. Its height above the ground after t seconds is represented by this function. Alright, so the first part is asking us how high above the ground is the object at 3 seconds. Okay, and so again, this function represents the height above the ground after a certain amount of time. So to find the answer for this problem, we are simply plugging in 3 in for t. Alright, so I'll plug 3 in for t and evaluate. So negative 4.9 times 3 squared plus 100. Okay, 55.9. So we get an answer for the first one. So at 3 seconds, this object is 55.9 feet above the ground. For the next question, what is the average speed of the object from 1 to 4 seconds? Okay, so again, that's average rate of change. Alright, so to find that average speed, we are going to take the function, we're using S, not F, evaluated at 4 minus the function evaluated at 1 divided by 4 minus 1, right? So average speed, right, that's average rate of change. And so the function evaluated at 4, we're plugging 4 in for t. Okay, about 75.60. Function evaluated at 1. $95.1. Alright, so here we got an average speed of negative 6.5 feet per second. Alright, so we gotta wonder, okay, why is the value negative? Well, again, because we are, right, talking about distance from the ground, right, that means that, right, that distance is definitely shrinking, right? If we're going to be starting off in the very top of the building at 100 meters above the building, right, as the object falls, the distance above the ground is decreasing. Okay, so that makes sense that this value is negative. If this value is positive, then we have to know that, okay, something's wrong because, right, we are dropping it from the top of the building, we're not throwing it up into the air. Alright, finally, it says what is the instantaneous speed of the object at t equals 4 seconds? So again, instantaneous speed means we're talking about the derivative. Alright, so let's go ahead and apply what we did in the previous example. So we want to find the derivative of this figure at t equals 4 seconds. Alright, so I'm going to go ahead and pause the video, and I want you to see if you can apply what we talked about today for this last example. Okay, so the approach for this instantaneous speed at t equals 4 seconds problem, and that is a derivative problem. So we talk about two ways of being able to find the derivative or the value of this function at 4. Again, you can either use this method, which again is the average rate of change method, or this method set up, which is using the difference quotient. Okay? Either one of these is going to get you the same answer, the right answer. Right? So let's go ahead and use this one, the average rate of change method. Alright, so we're finding this limit, so the limit as t approaches 4, so the function itself, so that's negative 4.9 t squared plus 100 minus that function evaluated at 4, okay, so it's 21.60, all over t minus 4. 4.9 t squared, 100 minus 21.6, 78.4. So again, we cannot evaluate this limit at 4 because that's going to make this function undefined. So let's go ahead and do some factoring. Let's take out a 4.9. You're left with t squared minus 16. Alright, so again, let's do some more factoring. So let's bring that up here. It's the difference of perfect squares, so it's t plus 4 minus 4. Okay, so t minus 4 is cancel. Alright, so we're left with this right here. So here I can plug 4 in for x. I'm sorry, in for t. So 4 plus 4 is 8 times negative 4.9. There you go. Alright, so this is the value of the instantaneous speed. What is the instantaneous speed of the object at t equals 4 seconds? It is negative 39.2 meters per second. Alright, that's it for today. If you guys have any questions, please let me know. You guys have a great day.